So in my last video I went over the difference quotient and pretty much how it works, and in this video I'm just going to be doing some practice problems. So the first one we're going to start with f of x equals 2x plus 17. So we can go ahead and break this up. This is how I like to do it, because you have to find f of x. We already have that. And you have to find f of x plus h. This is just 2x plus 17. And this is 2 times x plus h plus 17, which is 2x plus 2h plus 17. And these are the two things that we need to find to plug into the formula. And now we can just set up our notation. We already have f of x plus h minus over h. These cross out, and these cross out because it's subtracting. And so you're left with 2h. That simplifies down, and that'll just be 2. And this is demonstrated, let me redraw that. This is demonstrated in a graph. I'm not going to graph the whole thing, but we know that the y-intercept is 17. The x-intercept is negative 17 over 2. Let me redraw that. And although my drawing isn't the best, f of x is a linear line, so the slope is constantly the same, and that slope is always 2 no matter what the x is. So I'm going to move on to the next example. Now we're going to do practice problem number 2. And instead of this being a linear function, we're going to make it a quadratic, just to see how the slope changes and also the derivative. So let's go ahead and break this up. Obviously we have f of x, which is just x squared plus 4x plus 5. And then f of x plus h. It's going to be, we have x plus h, we plug that in, we get x squared plus 2xh plus h squared plus 4x plus 4h. I'm just doing mental math right now. So 4 times x plus h, then you distribute that, it'd be 4x plus 4h, and then plus 5. And then again, these are the two things that we need. Then we plug in to our limit notation and get x squared plus 2xh plus h squared plus 4x plus 4h plus 5, and that is all 1, minus x squared plus 4x plus 5 all over h. This can get a bit lengthy as you move into the higher degree polynomials, but typically it simplifies down a lot. You can see this crosses out, a 4x crosses out, and a 5 crosses out. Normally the whole f of x will simplify down, and that leaves us with 2xh plus h squared plus 4h all over h. And then we can rewrite this one as h times 2x plus h plus 4. It's a bit messy, but h 2x h plus 4. And what we want to do is we always want to try and get h out of the denominator, because when you plug in, you can't have 0 on the bottom because that'll make it undefined. This allows us to cross out h on the bottom, so now our formula won't be undefined. So we continue this of 2x plus h plus 4, which just equals, when you plug 0 in, 2x plus 0 plus 4. And the slope of the tangent line at point x is 2x plus 4. 2x plus 4 represents the derivative of f of x. This means that whatever point x we plug into the derivative, it will give us the instantaneous rate of change, or in other words, the slope at that point. If we were to find the instantaneous rate of change of f of x at point 1, we would plug 1 into the derivative, and it would give us 6. 2 times 1 plus 4 is 6. And that means the slope of the graph at x equals 1, or the slope of the tangent line, would be 6. Thank you for watching, and I hope this helps.